Welcome to everyone. We are houseful, almost only 2 to join. They are on the way. I've given them the web link to see wherever they are till they reach here. So, a very good morning to all of you. A famous word by Warren Buffett, a philanthropist, who said, "Someone is sitting in the shade today because someone planted a tree a long time ago. We are in the shade today because of the seed that was planted by Father Ignacimuthu in the month of September to call for this meeting today to sit under this shade." And who are the people who made it possible to sit under this shade are Father Rector. The community was immediately ready to welcome all of us. And Father Victor, the principal, young and energetic, dynamic person who made it possible here. And the 3 pillars are here to welcome all 3 chief guests among us who made also this event possible today. Dr. K N Ganeshaiah, the chief guest. Bible says, "Know the fruits by its tree." And today, Karnataka province is well known by its tree called Father Provincial Father Dionysius Vaz, who has made these fruits within the province possible to come out with intellectual caliber, research, and other involvement. And therefore, we have 3 people: the convener, Dr. Ignacimuthu, the provincial, Father Dionysius Vaz, and the chief guest, Dr. Ganeshaiah. I invite them to the stage here. I would request you all to stand for a minute of silence for the souls departed during this time of war, including the students from our country. Please be seated. In election-obsessed India, there is hardly any time to discuss the advance of modern science and the repercussions for public life. This exercise among the Jesuits make this vision of Father Arturo Sosa, the General of the Society, possible, that we must be men and women for others. And it is with this objective we have come together for this day and tomorrow to discuss and plan our vision for the future in terms of research, making science as an instrument for our simple people. And so I welcome the 3 pillars of the society and the 3 pillars of the institute here: Father Sweebert de Silva, the rector, Father Victor, the principal, and Dr. Melvin Colasso, to welcome our guests here. Since Father Ignacimuthu and Father Provincial are our own members of the family, there will be a shawl given by Father Sweebert and Dr. Melvin Colasso. Shawl. Thank you. Thank you. For the son of the soil, who is the chief guest today, is Dr. K N Ganeshaiah. We will welcome him in the traditional way of the state with a shawl, a garland, and Mysore peda by Father Victor, the principal. Thank you very much, Father Victor, Father Sripet, and Dr. Melvin Kolosov. In a short time, when I approached Father Provincial to honor us with his presence, in spite of his demand to be with the young priests in Mangaluru, he said, I will be there with you at 9:15 in the boardroom. And he was here to give us that gift of his presence. I welcome Father Dionysius Vaz, the provincial, to give us the presidential and the welcome address.
The chief guest of this function, Dr. Ganeshaiah, the convener of this meeting, our illustrious Father Dr. Ignacimuthu, the coordinator, Dr. Xavier, Father Xavier, Reverend Father Suibert de Silva, the rector of Arupe Nivas, Father Victor Lobo, the principal, Jesuits from all over South Asia who are present here, Dr. Melvin Culasso, and my dear friends. As Father Xavier said, I had a choice between being with Jesuits in science and to be with the young priests who are meeting in Mangalore today and tomorrow. And I chose this. I said I will meet them online. I will be meeting them online in the afternoon. But I'm extremely happy to be part of this inauguration of the meetings of Jesuits in science and technology on the theme Science as an Instrument of Our Mission. I think we are meeting in that synodal spirit of that Pope Francis speaks about, of participation, communion, and mission. And you are seeing how science can be an instrument of mission. And I'm sure there's going to be a lot of participation. There's going to be a lot of synergy here in terms of what is the contribution of science to the world of today. And I would like to speak about science, a little about science and justice maybe. That's my favorite topic, and sustainability that Dr. Xavier is bringing about in his Go Green for Sustainability. First of all, I want to warmly welcome you to the province. And I think this province is always a welcoming province, and Arupe Nivas is a very welcoming house. And I'm sure these 2 days will be a very nice time to have, apart from intellectual discussions, bordering on spirituality of science and so on. I'm sure this will be also a homecoming for many of you, a time to interact, to network and collaborate. So a warm welcome to you. It was Carl Sagan who said, science is a way of thinking much more than it is a body of knowledge. Science has to do with a sense of wonder, critical thinking, experimental orientation, and daring innovation. There is no logical way to the discovery of elemental laws. There is only the way of intuition, which is helped by a feeling for the order lying behind the appearance. The intuitive mind is a sacred gift, and I'm sure all of you will agree with me. Just as I'm a student of psychology, I was a student of science, I did my BSc, then moved on to psychology. And today, degree in psychology is a science degree. I've got an MS degree. And therefore, the intuitive mind is a sacred gift and the rational mind is a faithful servant. Unfortunately, we have created a society that honors the servant and has forgotten the gift. We give importance to the rational mind and the intuitive gift. Both are needed in science. Secondly, is there any link between science and justice? Yes, I would say. What constitutes a healthy natural environment and whether all humans have equal access to these essential supplies are justice-related questions on which scientists, you are biologists, physicists, chemists, earth scientists, and whatnot, can help to shed light. Today we are in a very dangerous situation where today Russia has just occupied a nuclear plant of Ukraine. That is where we need to really understand where can science reach to and where science can really benefit society. Example after example shows that the world's poor suffer the most from environmental degradation. Pope Francis has spoken much about it. And that it is the world's wealthy who contribute most to environmental damage, in large part through their highly disproportionate consumption of the world's resources. Scientists' work is essentially to understand and remedy this situation. Having the ability to generate such useful information, are you scientists morally bound to see that your research is used to help heal injustice? How does scientific research interact with the rest of society? First of all, to ask, in what geographic areas is scientific research conducted and how does it affect people in these areas? Let's take the pandemic, for example. You know, the vaccines. Thankfully, we had vaccines generated here. Otherwise, you know what would be our plight? You know, if you had got to, you know about the situation of HIV and the drugs that were created. Secondly, who ultimately benefits from this research? You know, pharmacy really made a big day during the pandemic. Second, the whole question of sustainable development. And I want to congratulate already Father Xavier for his book Go Green on sustainability for sustainability. It will be released very soon, but I want to congratulate him because later on I will not. I know his quiet time was time for really producing great research. Sustainable development is inextricably linked to sustaining peace. To achieve positive peace, we need to overcome social inequality, discrimination, marginalization, and poverty. On 2nd December 2020, the UN Secretary General Guterres, in the State of the Planet address at Columbia University, bluntly said, "Humanity is waging war on nature. This is suicidal." He listed some of the suicidal climate catastrophes. Biodiversity is collapsing. 1 million species are at risk of extinction. Ecosystems are disappearing before our eyes. Deserts are spreading. Wetlands are being lost. Every year we lose 10 million hectares of forests. Oceans are overfished and choking with plastic waste. The carbon dioxide they absorb is acidifying the seas. Coral reefs are bleached and dying. Air and water pollution are killing 9 million people annually, more than 6 times current toll of the pandemic. According to him, making peace with nature is the defining task of the 21st century. And we know with the Ukraine-Russia war, it is surely we need to be very proactive as Jesuits in science. To this effect, we need fundamental changes in values, worldviews, relationships among people and between people and nature. Sustainable Development Goal 16 is dedicated to the promotion of peaceful and inclusive societies for sustainable development, the provision of access to justice for all, and building accountable institutions at all levels. In the preamble to the Global Agenda 2030, we read, "There can be no sustainable development without peace, and no peace without sustainable development." Justice, peace, and ethics are embedded in concurrence to the progress and sustainability of nations across the world. I want to reiterate, justice, peace, and ethics are embedded in concurrence to the progress and sustainability of nations across the world. My call to you, dear brothers, is to say how we can bring about this through science. Thank you. God bless.
Thank you very much, Father Provincial, for bringing this churning within us. And I'm sure all of us will stand witness to his invitation. I now invite the chief guest of the day, Dr. K N Ganeshaiah, who has a prolific profile, but I will mention the key factors only about him in 3 words: an avid scientist, author, and traveler. His specializations involve forestry and environmental science, biodiversity and eco-informatics is his latest contribution, in which he is mapping the bioresources and digital inventory of plant resources. A Fulbright Fellow with 15 PhD guiding factors in his profile and 150 national and international talks delivered, and as a writer, in English it is numbers possible, in Kannada there are many which are innumerable. And when you type Dr. K N Ganeshaiah kits in Amazon, a set of 21 books together, 24 books together comes as K N Ganeshaiah kit. And therefore, it is a pleasure for me. I want to thank Dr. Prabhakar, who had given his name to be brought amidst us. And I want to thank my head of the department, Dr. Prabhakar, who is instrumental in bringing Dr. K N Ganeshaiah among us. Over to you, sir.
That mic, yes, okay. Yes, I'll be using this. No button. On. Turn down. Maybe I can use the hand one or not. Use it. Okay. So I'll be moving, and so it might be falling up, and so I would still, I think, prefer.
It's fine, sir. You can just leave it there.
Oh, it is fine. Okay. Am I audible?
Yes.
Actually, I can also speak without even the mic if you can all hear that. Okay.
Yeah.
Is it fine?
Yeah.
Okay. Don't worry, even if it doesn't work, I can speak loud. Yeah. Dr. Xavier sent me a mail telling that I'm going to meet a group of Jesuits. That itself was very exciting to me. And thank you for inviting to me amidst, as our provincial director rightly told, the intellectual mass of this province. But when I received the mail, I did not know as to what should be the theme of my talk. As he spoke about me, I've been working in biodiversity and ecological work, but I did not want to now speak anything on my personal work as such, because I thought that I can preserve or reserve for some other occasion. Since we are now discussing here as science as a mission for the human welfare, I thought I will perhaps now discuss with you something on the relation between science and religion, or the two areas of our endeavors seeking towards a common truth, and that shall be the theme of my talk. I like to start this with two instances from two separate religions, one of Saint Thomas and other of preaching Bhagavad Gita. And with that, I want to now ask, do they differ in seeking truth? The science and religion, do they differ in seeking truth? But let me now place a preamble to explain why I have brought those two instances to discuss for discussion here. At least I am told since when I was young, that science and religion differ on 3 or 4 aspects very clearly. Number one, it's believed, or we are told, that science always has this questioning ability. Without questioning, science does not accept anything at all. And it's also told that science always demands proof for whatever the answers get for those questions. And that science always goes for logical reasoning, and science does not believe in faith. This is what we are all told about this science. And not many scientists who argue for science feel very proud about this. And on the contrary, if you now look at religion, it exactly is opposite. At least that's what we are told. That religion relies always on faith. It does not now promote questioning about anything, and it does not depend on logical reasoning and does not demand proof. Now, the reason why I showed those two slides and those two images is to exactly prove that all this is wrong. But let me tell you, let me start with this famous example of Saint Thomas. I don't need to tell you who Saint Thomas is, the disciple of Christ. He came to India apparently, carrying the message of Christ. But the story that I am going to tell is beyond that. As you all know, Jesus came back to life apparently, and he saved Lazarus. He brought Lazarus back from this dead life. But when this event happened, Thomas was not there. But when Thomas arrived, he was told that Christ came back from his crucifixion and he saved Lazarus. But when he was told, Thomas could not believe it. He did not believe, and in fact, what he told was that I would like to now agree with you that Christ came and gave life to Lazarus only when I see the proof for that. In fact, the exact words he is supposed to have told is that unless I see the nail marks in his hands to put my finger where the nails were, I will not believe. This is exactly what he is supposed to have told. Please note the red lines that I have marked there. Unless I see, I will not believe. Whatever the event is, what Thomas is telling here is that unless he now sees, unless he gets the proof for that, he will not believe. Now see here exactly what is done by Saint Thomas, for which reason is also called as doubting Thomas. And today, doubting Thomas is viewed very negatively, but actually what Thomas has done is an important component of science, that is doubting everything, demanding the proof. The two most important components of science are exhibited by the very way in which Thomas actually lived and demanded that he be now shown proof for the story that he was told. So in other words, in the story of Saint Thomas, we do see elements of science. He demanded proof. He accepted only after observing and experimentation that he put his finger into the holes where the nails were, and both of them, demanding proof and observing and experimentation, are the hallmarks of science, as you know. In other words, it is wrong to believe that religion does not demand proof. Religion does not question. There is this famous photograph by the artist Mark Tansey to ridicule what science is. Sometimes how science goes to the extreme level of demanding proof. What is this? There is an earthquake there and the earth is broken, and here is a scientist who puts his hand into the broken earth, because even if he sees that the earth is broken, he wouldn't believe. He would like to put his hand in between the broken pieces of earth and then thinks that yes, earthquake breaks the earth. I mean, this is a ridicule level to which sometimes scientists also go. Now coming back to the other element that I wanted to share with you about the Bhagavad Gita. You all know that when the Mahabharata war started, Arjuna decided that I will not fight with my own blood relatives, my brothers and my cousins. And so Krishna was to now preach him Bhagavad Gita. And by preaching Bhagavad Gita, what did Krishna did? He converted Arjuna, who was not willing to wage war and kill his brothers and cousins, to wage war or to take his arrow and bow and to jump into the war and kill his own brothers and cousins. Now look here, a person who is not willing to take his bow and arrow was convinced to take his bow and arrow and also go and kill his own brothers and cousins. There was a logical, internally consistent logic that Krishna preached to Arjuna so that he changed his mind and actually jumped into the war. Now the important element of the science is logical reasoning. We do see that any number of times we see this kind of stories where even in religion there is a logical reasoning. In other words, reason is an hallmark of science that is also found in religion. So it is wrong to always assume that only science believes in questioning and proof and religion always depends on faith. Let us now look at the other component of the faith. It is generally told that religion only lays on faith and science does not have any faith at all. But on the contrary, you will see that if you ask the question, one of the beliefs science has got is that science can explain everything and so you don't need anything else. That is one of the greatest beliefs in science. But if you ask this question, can science explain everything? There is no proof for that. It's only a belief. In other words, if you now look at whether scientists have also got beliefs, just as, let us say, the religious people have got belief on the God, yes, science also has beliefs, because this is an assumption. What is an assumption? That science can explain everything is an assumption that is untested so far, and so it remains as a faith. And so, in other words, this most important element or the pillar of science, that it can explain everything, is also an element of faith on which the entire scientific community believes. So science and religion, in other words, as you could see, there is faith in science and there is a rationality and proof in science. And so science and religion, as you can see, actually share a lot of things in common. But it is very, very surprising that in the entire human civilization, science and religion are always viewed as two opposing ends. But I am very happy that in here we now see the religious experts sitting to discuss on science. Believe me, there is no more a better happy moment for me than looking at this kind of discussion. Because as a scientist, what we are told is that religious people do not care about science at all. And in that context, I am very happy, and I really like to compliment all the organizers, Ignacimuthu and the entire community here. And for that reason, I am very happy to be here to come and share what I want to share with you. So in other words, I would like to now always suggest the following, and this is my take-home statement that I always give whenever I am in such discussions. What is that? I would say to scientists, don't discard religion, see science in faith. There is always an element of science in every faith that we perhaps can think of. And I also would like to tell to the religious experts that have faith in science. And these are the two elements I would like to discuss in the next 15-20 minutes. For scientists, I would say, seek science in faith, and for religious people, have faith in science. Now let me take the first point here. How do we now seek science in faith? I'd like to take you through this example of what actually happened in my own village over a traditional practice that we were following. And this traditional practice had a faith in it. What is that? This particular structure that you see called Gudane has ghosts in it, and it can control the pests of the grains that we store in our village. That was a faith. And whom you see here is my mother. She is holding a Gudane. Now what is this Gudane? Imagine two clay saucers kept one over the other. Bottom is intact, but the top is whole. They are all sealed. That is Gudane. Now this Gudane is used to protect pulse seeds in our village. When I was very young, it was a common practice. What we used to do, you all know that in villages, seeds were being stored in bins, or what we call gudana. They are called gudanas or bins. Now this gudani that I showed so far was kept inside this gudana or the bin. Seeds were filled up till half. This gudani is kept inside, and over that the seeds are poured. It is closed on the top. So as and when we want seeds, we now start taking the seeds from the top, and as seeds get exhausted, and when we come to the stage or level where this gudani is kept, the kids used to be called. Now before that, one important thing that was being done before this gudani was kept inside the bin was that the whole gudani was put into the bucket of water. There are holes on the top, water gets into, so water is there at the base because the base is intact, and it is dried in the shade, but the water is still there. So the dried gudani is kept into the bin. So then the seeds are filled. So as the seeds are harvested, when we reach this stage, the kids used to be called. We were given this gudani, and we were told there is ghost inside. Don't look into it. So keep the gudanis behind you, run to the tank, village tank, turn towards the village tank, throw into the water. Don't look back. If you look back, ghost will catch you. And run back home. And we used to run back, shouting that, oh, I have thrown the ghost into the tank. And the moment we come back, they used to hold us and pour hot water on us so that if at all there is an element of ghost stuck to that, it is now washed off. This was a practice. And we as kids used to fight to carry this ghost and throw into the tank because we become heroes there, you see. I have thrown the ghost into the. This was the story. So, in other words, let me recap. The ghosts are supposed to have entered into the Gudani, and as I told you, we used to dispose it off so that the ghost goes off. We are not supposed to break on the way. If we are, by chance, if we break, the ghost will come out and will engulf us. And so we were kept outside the house for about the whole day before we are made to enter inside. Sorry. So what is this ghost? Obviously, we all simply accepted it, and as I told, we believed in it, and there was a faith in it that this ghost is there to protect the seeds. A 10th standard girl from Bangalore came to our village in one of her trips, and she wanted to probe this. She wanted to ask, what is this Gudani ghost? So what she did was, she did not listen to the elders that the ghost will, engulf her if she breaks. She now secretly took one Gudani and broke it. And she found that inside that Gudani, there were some insects. I'm sure Ignacimuthu will be very happy to listen to that. What are these insects? These are what are called pulse beetles or bruchids, which actually eat the seeds of the pulses. So clearly, this Gudani is actually attracting the pests of the seeds, and it is in fact protecting the seeds. But what is the ghost here? How is it doing? And what is happening? How is that this Gudani is actually attracting these insects? So what this girl did was, she didn't know what these insects were. She brought these insects, showed to the experts in our university, and they found that they all were actually dead inside the water that was there in the base of the intact Gudani. And the scientists there told, maybe there is some traditional way of controlling the pests of the pulses here. And so what you see here is a perhaps well-tested traditional process of controlling the pests of the village. But what is this ghost? And how is that the Gudani is trapping the insects? So these pests actually lay eggs on the seeds like that. You might have seen these seeds. The seed hatches, larva gets into the seed, it eats the seed and pupates inside and then comes out as the adult bruchid. So that's why you see the holes there. Once the larva eats the whole food, the bruchid comes out. But as the new generation of bruchids come, they have to mate with each other so that they continue the life cycle. To find the mate, both males and females have to now crawl through the seeds. And how do they crawl? They crawl like that. They have developed this instinct of finding the mate by going through the crevices available between the seeds. In other words, they have an instinctive ability to now move in the small crevices. When they are doing so, if they happen to now come across the whole of the Gudani, without their knowledge, by instinct, they get into that crevice or that hole and they get trapped in the Gudani. And what is there at the base of the Gudani? Water. So it gets trapped there. So in other words, there is a biological control method of the population of the bruchids, because when you trap the potential males and females, reproduction is stopped and so the pulses are protected. But what is the ghost here? Why is that people have told there is ghost inside, don't break it, don't open it? Imagine what happens when these bruchids are trapped in the water for months together. There is moisture there, fungus grows, spores get produced, and if you happen to now inhale the spores, you are likely to get the respirational problems. And if you break, the spores distribute, not only the one who is carrying, but everyone around also will be infected with the spores. You are likely to get the asthma-like problems. And so that we are told that you have to run to the tank and throw into the water so that the whole spores go inside. Now she investigated this and she now actually produced this as a work to be presented at the national level in the Children's Science Congress, and she got the award. What is more important is just not that. When I became the Dean of Postgraduate Studies, I happened to meet a Dean from the Tamil Nadu University on a meeting like this, and when I was telling there was this kind of very interesting investigation by a girl student, he told, look here, in Coimbatore, in Tamil Nadu Agriculture University, the same kind of method has been developed based on the scientific method of the understanding of the behavior of these crooked beetles, and we have developed a technique like this. It is available and it is being sold. The only difference is, look at the same kind of holes on the top, but at the base, instead of water, they have put the pesticide in a vial. So this is scientifically proven. Whereas in my village, you are simply following the by faith. What you would like to appreciate here is that the tradition in our village was surviving purely by faith. And there was a sense and also a science behind this faith. In other words, we all need to perhaps look for science in the faith that we hear, and there may be a lot of logical basis for all of that. Now let me move ahead and come to the second point. The second thing I told was have faith in science. I don't need to really preach about this to the Jesuits because from a long time we do see that religious people are involving in science. I would like to now put across two examples, one of Gregor Mendel, whom I'm sure many would know here, and another Father Saldana, who is actually from the same institute. I'll come to Saldana a little later. Let us go to Mendel's work. And what I want to do here is take Mendel's work and derive some lessons for the purpose for which we are sitting down here. So what is that Mendel did? I don't need to explain. All of you know very clearly. He came out with the 3 laws of genetics, laws of inheritance of the characters. His work was very simple. He was an abbot in a church. What he did was, he crossed a tall plant and a dwarf plant. And the next generation, he got a tall plant. So he concluded that when you cross tall and dwarf, tall takes over and that is the dominant character. But when he he got 3:1 ratio of tall to dwarf. From that he derived the laws of genetics. Details are not important for us. What is important for us from Mendel's experience is the following. Number 1. Why did Mendel, and Mendel's work, as you know, would remain as long as civilization would remain. I mean, he is in fact in the entire biology the greatest scientist, much more than so-called scientists, because his work is basic, fundamental, not just the pillar, it is the foundation for the entire biology of the modern era, whether biotechnology or evolution. Now, such a great work you could do simply by asking the right question. And I would like to now tell here that perhaps if anyone is starting research work, whether it's PhD scholars or an institute that is now starting, the most important thing I think we should learn from Mendel's work is that we should now start asking the right question. His question was, how are the characters inherited? But it laid the foundation for the entire biology. And the second most important lesson we can learn from Mendel's work is that he did not use any sophisticated lab at all. He did his work with the least cost. What is the cost it involved? He simply, anyway he had to cultivate the peas. He was cultivating the peas. But he grew them, he crossed them, he selfed them and counted which are the tall plants, which are the dwarf plants. The regular cultivation, he adapted the methodology and he also got the peas, but he also got the data. There was no need of sophisticated labs for his work. And number 3, patience. One of the unfortunate things with the institutes or research is that you give the fund today and tomorrow the student or the scholar is asked to produce the results. Sadly, we are losing patience. Science, I'm sure, requires patience. Good results, great results come only after some patience. And Mendel had that patience. Every generation he had to know sow, and 3 to 4 generations he had to know go, which means about 3 to 4 years. 3 to 4 years he did not expect anything out of his work at all. Only at the end of 4 years he got the 3:1 ratio. And the most important, and the fourth is, he married between the disciplines. On one hand, he was working on genetics, on the other hand, he had statistics. Look here, his number of plants he got tall and dwarf are 787 and 277. The ratio was 2.84:1. Any other person other than Mendel would not have seen any meaning in it. But he rounded off 2.84 and told it is 3:1 and fit statistical tools for that and showed that all other characters are following 3:1, and that was the thumping success for Mendel. And why he could do so? Because Mendel was statistically also oriented. So by marrying statistics with the biology, Mendel could break the barriers or the walls that were existing so far. So one of the important lessons I would like to rather learn from him is that if you want to know break barriers, don't go only with your own science or with your own field, marry between the areas. Now what I am going to do in the next 15 minutes is take each one among them, restate them and give an example to each one among them. For instance, asking the right question is fundamental to science, fundamental to any area of science. Great discoveries can be made with least cost. And number 3, great results require another cost, that is patience. And number 4, marrying ideas is most rewarding in science. Let me take the first one, asking the right question. Now, and that's where Saldanha comes in here. It's about 1983, Saldanha was in the same institute. He was greatest taxonomist of the time. We all heard about Professor Saldanha. And in this context, we happened to meet Professor Saldanha because myself and my colleague had a fantastic idea to now do our research. That was our early days. We were looking for what area we can work on, what is that we can work on. We found that the plants of the family called Euphorbiaceae have one peculiar feature other than the other plants or the other families. What is that? The male flowers and female flowers are different in Euphorbiaceae. Whereas in all other plants, males and females are together in the same flower. The male organs and female organs are separated into separate flowers in Euphorbiaceae. So males are different and females are different. And what is else is that we could also count how many flowers of males are there and how many female flowers are there, and we can find a sex ratio. This much we knew. Immediately, we jumped into a conclusion. What is that? We can perhaps work on the evolution of sex ratio in Euphorbiaceae. We became excited. We came down here. We met Professor Saldanha and told him, sir, we want to work on the evolution of sex ratio of Euphorbiaceae. Professor Saldanha gave a sly smile and told, my dear son, the question you are asking or the topic you are trying to now address is too unwieldy. It's too vague a question. I don't think you really can go forward at all. Do one thing, ask a specific question and address it. Maybe you'll be succeeding. Believe me, myself and my colleague who came here were thoroughly disappointed by Professor Saldanha, and we went back. We were sitting in the bus. Before two stations crossed, we thought maybe let us also now think of a question. And then we thought a question. Does sex ratio change with the habit of the Euphorbiaceae? Meaning, when we move from herbs to shrubs to trees, does the sex ratio change? Can this be a good question? We got down from the bus, ran back to St. Joseph's this college, went back to him, sorry sir to disturb you again. So can this be a question? He called both of us on either side, patted our back, go ahead, I'm with you, do this one. So the right question is to be now encouraged by the leaders. And thanks to Saldanha, please give me a big clap on my behalf. And lo and behold, we went about and did that work and published in the paper. We found that from herbs to shrubs to trees, sex ratio goes on increasing. That gave us another question. Why should it increase? Why can't it decrease? And so it went on, and this actually became the basis for all our work in plant reproductive strategies. So thanks to Saldanha for focusing for this question, a specific question. And today we are known as, myself and my colleague Uma Shankar are known as people working in plant reproductive strategies because we started off from this one small advice from Saldanha. So asking the right question is so important. And then great discoveries can be made with the least cost. This is another lesson that we can learn from Mendel. I like to give another example here, again from my own experience. This lady came from Chennai to work with us under what is called as Indian Academy Summer Fellowship. And this is something that you would all like to know. Indian Academy provides every year some 300 fellowships where any student who is doing BSc or MSc can attach himself or herself to any professor in the country, can go and stay with that professor for 2 to 3 months and work with him so that he or she picks up the spirit of science and spirit of doing work. These are available and you can encourage any of your students also to do this. She came under one of those fellowships, IAS or Indian Academy of Science Summer Fellowships. Today it's called Academy Summer Fellowship because of the success it gained, all the 3 academies together have joined and they're funding this program. It's a very successful program and all of you actually can make use of this. She came and she told, these youngsters have a very peculiar idea. What is that? Today biotechnology is going on, DNA work is going on. If I work in DNA, maybe I'll be picked up for a job. So she came and told, sir, I want to work on DNA. Ganapriya, her name is Ganapriya. Ganapriya, very good, you love DNA work. But what is it you want to work on? Anything, sir, anything on DNA. We had the lesson from Saldana. What is the lesson from Saldana? Ask a question. Without asking a question, you are not doing science. So we simply repeated what Saldana told to this lady Ganapriya. Ganapriya, you should have a question. Sir, but how can I develop a question, sir? I want to work on DNA, but you give me the question, sir. This is the wrong answer. Now, you can't expect the teacher to give you unless you are interested in it. So what we did was, we told her, look here, let us go for a trip. We recently going for a trip, and a picnic. Let us go for a trip. And the way maybe let us discuss and see what is that your interest is. And then maybe we will see what is that we can do or what is that we can do. We went to Kokre Belur. Some of you from around here would know that Kokre Belur is a place where a lot of, once in a year, migratory birds called the painted storks come there and they breed there and again depart back to Siberia and those places. And these are those birds. So we went there in the morning, were looking around. The area was very exciting for us. We sat through the area and sometime in the evening, we saw this scene. The storks were carrying twigs in their mouth. Believe me, this girl who wanted to work on DNA, she asked the question, sir, why are they carrying twigs? They should carry fish or any insects for their babies. I turned to her and told, Ganapriya, I have got a question for your 3 months work. So I told, go ahead and ask why it is carrying a twig instead of a food. She took the binoculars and then spent about 15 days in that place and found out very interesting things. What is that? First of all, it is surprising for us to know that these birds prepare bed for their youngsters almost every day. And what is the bed prepared out of? Bed is prepared out of the sticks that they are carrying in the evening. So they carry these sticks, every day they change these sticks and prepare the fresh bed, and so every day they have to carry one twig along with the food also. Food they carry and feed, but the twigs also they require. Up till here she came, you see how once you are into that groove, you start pursuing yourself. She found out they are carrying the twigs for preparing the beds, and the second question she herself asked was, what twigs do they carry? There are so many trees in the whole of that area. Do they carry any specific twig of a particular species, or they generally carry everything? We told, go ahead and test it. So she now collected, maybe they prefer a specific tree, or they may not, but if they are preferring a specific tree, why should they prefer a specific tree? So she collected this, they throw out the bed every day. You can go and collect it, and you can meet a taxonomist, and with some, expertise, you can actually identify them. And she identified, and she found that more frequently they are carrying Thespecia papulea twigs. Why should that be? Why should it carry this? They also carry other twigs, but more frequently Thespecia papulea. So she came back with the results and told, sir, I have discovered that these birds carry Thespecia papulea, but I want to know why it is carrying Thespecia papulea. My colleague Uma Shankar is a doubting Thomas. He asked the question, so you say it carries Thespecia papulea. That may be because Thespecia papulea is abundantly available in that area and not because the bird prefers. So even if it is a machine, it goes and picks Thespecia because it is abundantly available in the area. So she was sent back. She went and in the 4-kilometer radius, she collected the data on what plants are available in that area. And Thespecia papulea is in fact abundantly available. But again, Mendel helped us. Remember, Mendel combined biology with statistics. So when we put the statistics, we found that though Thespecia is abundantly available, the frequency with which the bird carries is much more than what is available in the surroundings. Means what? It is preferring Thespecia papulea. And so this is Thespecia papulea. She now then collected the twigs of this, ground it, and put on to what is called mites. Mites are the ones that actually affect the body, and that's the most frequent pest around there. She put on the mites. Don't bother about the details. Just see that 5%, 10%, 20%. Don't bother about this. As the concentration of the dry matter of the twigs goes on increasing in the solution, mite mortality increases. Means birds are using the twigs of Thespecia because it has an acaricidal or mite killing ability. Look at the discovery. Now we have discovered medicine for. So she wanted to actually go ahead and she now wanted to collect the literature. Unfortunately for us, it is already known. The Siddham literature already has in the website that poor so are Thespecia papillia as a medicinal suggestion for skin problems, dermatitis problems. So apparently it is known. But that failure is not to be now seen as a disappointment. The fact that she went through the whole process of scientific investigation and found the way that without DNA it can also do work was what was to me the most pleasing things. So in other words, it's possible to discover things without sophisticated labs, and good work demands persuasion and patience. Now I have an example here from a very famous story that goes with this lady called Jane Goodall. I'm sure all of you know about Jane Goodall, right? Jane Goodall is a lady who now took conservation of the chimpanzees in her whole life. She dedicated her life for conservation of chimpanzees, and she has a lab in Tanzania, and the lab is called the Chimp Group. It's called Chimp Group because there is no lab. The group that is studying chimpanzees itself is the lab there. So one day, Jane Goodall is very well known in the world. Lot of youngsters are attracted to her. One girl went to her and told, "Madam, I want to know work on chimpanzees." Jane Goodall accepted her. Good. She gave a notebook and a pencil to her and told her, go and start working with the chimpanzees. She has only a notebook and a pencil. She goes and observes chimpanzees, comes back. Next day she goes, comes back. Third day she goes, comes back. 10 days it went on like that. Then she went to Jane Goodall and told, "Madam, I don't know what to do. 10 days I've spent here, but there is not even a single element on my notebook that I can note down." Jane Goodall told, "My dear, you need to have patience to work with anything. It's just not enough if you get up early morning at 8 o'clock and come back by 4 o'clock. Science does not work with the office timings. Chimpanzees don't behave to your office timings. If you want to know work with the chimpanzees, you have to know have patience. You have to love them. You have to live with them." So she told, "Go and live with them." And I have lived with them. In fact, Jane Goodall has lived with them. So she went, and because Jane Goodall told you have to live with them and love them, this girl began sleeping with them. There will be a so-called nest of the group of chimpanzees. She started sleeping by the side of this nest. 3-4 days happened, nothing happened. But one day morning, at 4 o'clock, she saw some disturbance in the nest of chimpanzees. She got up and she saw that one chimpanzee got up and without doing anything, went straight to a particular plant almost 3 kilometers away, took the leaves of the plant, swallowed it, came back and slept by 5 o'clock. 4 o'clock it has got up, 5 o'clock it has come back. Chimpanzees are very lazy. They get up at around 7:30 and then they stretch their right leg, left leg, and then they look back and forth and then examine the trees. Slowly they get up and the group follows. But this chimpanzee, she ran at 6 o'clock in the morning to Jane Goodall and told, "Madam, I don't need this notebook. I'll tell you what I observed." She told Jane Goodall. And Jane Goodall heard this and told, "You have earned your PhD." That one observation as to why one chimpanzee got up early in the morning, walked 3 kilometers all the way, and ate a roll and came back and slept. She told, "You have earned a PhD. Go back and see that chimpanzee. What is specialty with that compared to others?" It turned out that when she examined she saw so many things. One among them is that it had 2.5 degrees extra temperature than other chimpanzees. She tracked it the whole day and she found that in its fecal matter there are a lot of worms. And the worms were all coming out dying. And then for her luck, the next day also it went to the same plant at 4 o'clock in the morning. She tracked it and she found carefully. What was very surprising was that it was not swallowing the leaves as such, it was rolling on one side and swallowing. Immediately caught hold of the leaves and she now sent to the experts, and they found that under the undersurface of that leaf there are some glands which produce a broad range antiseptic or antibiotic which can kill the worms in the stomach. And why was it rolling? It was rolling so that it goes and bursts only in the intestine, not in the crop. Like we eat capsules, the antibiotic capsules. So chimpanzees have discovered capsules and antibiotics much before any of us. But then she wanted to know, I mean, all this became a famous work. Then she wanted to know, how did chimpanzees learn? She went around the area, there were some tribal people there. She asked the tribal people, and the tribal people told they were also using the same leaf. So she thought chimpanzees have learned from those tribal people. So she asked the tribal people, how did you learn this? They told, we learned from chimpanzees. In other words, our medical system seems to have been now flowed down to us by some of the animals. You all have heard about the way cats behave, dogs behave, they eat. So there is so much. And in fact, this girl's work today is known as zoo pharmacognosy. Zoo means animals, pharma means medicine, cognosy, discovering. Discovering medicines from the animals. It's a huge field, and pharmacy companies are spending billions of dollars to observe animals, the peculiar behavior of animals. You can discover the snake bite medicine by looking at what a monkey would do when a snake bites it. Because they know more than perhaps we the human beings. So in other words, this girl had patience to live with the, so Jane Goodall told, have patience and love the system. And she did, and she got her PhD, and they're fantastic work. I'll skip all this that I'm telling is the same thing. Okay. So the last is, Mendel exploited on the gap areas. He married the two areas. And give me 5 minutes, is it okay? Yeah. And I would like to tell this last story because again it has some link with this institute. The story I'm going to tell is about this girl. Now what is the story? This girl once went on a truck, regular picnic, regular truck. And there is this place called Ombattu Gudda in Karnataka. She went to Ombattu Gudda and she was lying down on the rocks there along with her friends one day afternoon. And she found that one particular part was falling from a tall tree, gyrating like the blades of an helicopter. The blades of a helicopter start turning. Like that, this particular part or seed was with the wings, was turning around from the treetop and was falling. She was just a student and she wanted to really know what it is. She collected these seeds and came back. She collected those samples and came back. And when the house, she dropped again the same parts. And in the house also they were gyrating and they were falling like helicopter blade. So she became interested. Why is that these seeds are gyrating when so many other plants don't gyrate? And what makes it gyrate? So she went on investigating. And she also found some peculiarities. First of all, in these seeds are five-winged. You can see the 5 wings there. And they disperse by wind when they're dry. And so what happens, when they rotate in the air for long, they stay in the air for long. And so when the wind blows, their dispersal is enhanced. They are carried to farther distances. So more you gyrate in the air, more the dispersal you get, more the advantage you get. This she learned. But the questions she asked were very peculiar. What is that? So they rotate while falling down, like the wings of a helicopter. And she found that 80% of them rotate in the clockwise direction, 20% rotate in the anti-clockwise direction. Why is that? Number one. Number two, she also found, as I told, that there are 5 wings. Why should there be only 5 wings? Why can't be 4 wings? Why can't be 3 wings? Why can't be 6 wings? And she also found that there are some peculiarities. There is always one small wing separating 2 large wings. So all these questions she raised, I will not go into all those details. I will only now tell one question that she asked and the answers to that. What is that? She asked the question, why 5 wings? Why not 2? Why not 3? Why not 4? Why not 6? She created models out of it. The paper models, like this. One folded paper like wings and one weight in the center. She dropped it with the 2 wings. She dropped it with the 3 wings, 4 wings, 5 wings and 6 wings. Now what is that? I told, more they stay in the air, more dispersal. So she tracked how much time it takes for them to reach the ground. So more the time it takes, better for the plant. And so she tracked the time taken to reach the ground, and she finds that in fact the increase in number of wings, the time taken goes on increasing. The time taken goes on increasing, and it suddenly increases at the 5 wings. It also has better settling ability or better dispersal at the 6 wings, but the amount of increase you get with the 6th wing is very, very little compared to the 5th wing, And so it appears that 6 wings are of course efficient, but 5 are enough, because having an extra wing is not so advantageous. So she answered the question. Now, what is more important is that she produced this as a report to Karnataka government, which gives these fellowships for the young kids, and she got this KVPY fellowship, which provides her fellowship up to her PhD. And this girl eventually did her PhD in cosmology in Netherlands, and now she is doing her postdoctoral fellowship in Israel, and she is from this college. So I think you would all like to know, be a big clap to her. The small secret and the selfishness that I have in telling this story is that she is my daughter. Now, I am going to conclude now. So we learned lessons from the Mendel, that these Mendel's lessons also have a message for perhaps the task that you are all coming here with. What is that? How do we start a new institute? I am not going to preach anything, only derive some lessons out of what Mendel did. Number one, as I told, great discoveries can be made with least cost. So my suggestion to you all is that promote in the beginning least cost research, but don't hesitate from building the labs. Build them, they may be also required. Number two, great results come with a lot of patience. So please have patience. When you give funds, don't demand them to show accreditation report next year, some outcome out of it. Scientists are not magicians. I'm sure Ignacimuthu knows that very well. You need to have patience. So you got to really bear with the research community, but promote that patience among young. Youngsters are losing patience. They also want to now produce a lot of results, and so they do lot many things. Promote patience in youngsters so that good research comes about. Gap areas are most rewarding, which means what? We have to know actually network them. We have to integrate different fields. So allow people to discuss among disciplines. We may not know how physics and statistics may help a biotechnology man, and we may not know how a chemistry perhaps would help a psychology man. I'm sure our director would now know that there are chemicals that are involved in psychology, and so we don't know what lies where. So it's good to now promote interdisciplinary work and interdisciplinary interactions, not just within the institute, but also promote across institutes. Let your people go to other organizations like A-Tree or NCDS, University of Agricultural Sciences, Bangalore University. There are advantages. You can harvest their knowledge, but also can collaborate with them with their labs, so that your institute, organization, research unit can perhaps build. So nourish mentoring from outside also, both for knowledge and for collaboration. Finally, I end my talk again stating to the scientists that you have to seek science in faith, and to the community of your kind that have faith in science. Thank you very much.
Sir, please be.
Father Provincial, please. Thank you very much, Dr. K N Ganeshaiah, for that wonderful illumination of ideas with the theme for the summit that we have, that science become as an instrument in our mission, with concrete example, bringing in alive to us our own Jesuits among us, Father Saldana of this province, the right questioning for any research. Even with the least cost, we can bring out big discoveries, the value of patience for research, and marrying of ideas among various disciplines. So beautiful, so down to earth. We are so touched by your presentation. Please give him a good round of applause. Now it gives me immense pleasure to speak of the hand in labor of love by two eminent scientists in this gathering. One I will speak, the other Father Divya will speak to us. Father Dr. Ignacimuthu, who has been a Vice Chancellor of 2 universities and a stalwart with more than 80 books, 800 research papers, 2 US patents, has brought 2 more patents. It's with me right away. After this session, I will display it over there at the center table. 150 Jesuits contributions to science made into a jewel by the title The Contribution of Jesuits to Science in India, dating back from today 100 years backward, a century's achievement by scientists in the title The Contribution of Jesuits to Science in India. It would be fitting on this occasion to request a visionary scientist, Dr. K N Ganeshaiah, to release the book and give the copy to Reverend Father Provincial, Father Dionysius Vaz. The copy.
Simple activity. No need to put
Perhaps the raise function has to be made more simple than this. Wow. Yeah.
Congratulations.
I would also request Father Ignacimuthu, the author of the book, to gift the first copy to our chief guest, Dr. K N Ganeshaiah, and stand together for a group photograph. Three of you.
Thank you, Father. This was innovative.
I stand here with a heart filled with praise for the person as Father Xavier Savarimuthu, whose hard work I witnessed during the treasureship, during my stay at Mount St. Joseph, Bangalore. During his sabbatical, Father Xavier left no stone unturned by dedicating each minute to come out with his edited volume with two other international editors on the book titled Go Green for Environmental Sustainability with a renowned international publication group, Taylor and Francis, Florida, USA, Oxford, UK. I used to play basketball with him. As soon as he finishes game, he will not spare time. I had to go and write books. Every day practically is locked and the outcome is really great. I know how difficult it is to publish a book in Taylor and Francis. I myself struggling today to publish one article. That one, it will cost more than 1.5 lakh, but it will take almost 2 to 3 years to publish one article in these publications. I know, Father, it was really amazing work I did. I witnessed myself. I stay over there. He may be a youngest Jesuit who has been internationally invited and endowed with the chair position, the Jesuit universities of USA. The latest feather to his cap was when he addressed on the topic Water and Human Rights in Oxford University, UK. Already to his credit, he has a textbook titled Fundamentals of Environmental Studies. May I request our beloved provincial Father Dionysius Vaz, who gave accommodation to his labor of love, Go Green for Environmental Sustainability, to release the book and give the first copy to none other than our chief guest, Dr. K N Ganeshaiah. I also request the chief guest editor of the volume, Father Dr. Xavier Savarimuthu, to give the first copy to Reverend Provincial as a mark of profound respect and gratitude. I invite both the authors with the dignitaries for a group photograph. Thank you, fathers. Thank you.
Wonderful.
So we are almost at the end of our inaugural ceremony. I invite my good friend Dr. Joji Linga Reddy to honor us with his vote of thanks.
Before that. Before that, I would like to read out the message from Father President of South Asian Assistancy, Father Stani, who has sent us a message, okay? It's a bit long one, but I have shortened it, which is fitting into us here. My dear friends, at the outset, please accept my warm greetings to you as Jesuits of South Asia gathered in St. Joseph's College, Bangalore on the theme Science as an Instrument of Our Mission and to share your best practices in this direction. It is indeed good news, I pray, as it is in the myth. Samudra Madana, your deliberation may also ultimately open the springs of nectar so that all may find abundant life in and through you and your mission of scientific studies and research. We are in the context of a synod ushered in by Pope Francis. The synodality of Pope Francis includes 4 parts: inclusive participation, attentive listening, shared responsibility, and deep renewal. I'm happy that you have inserted synodal aspects in your conversation. I see in your schedule time to speak and listen. However, I suggest that you try to take this meeting to another level so that it engenders renewal, which takes shared responsibility for each one's growth. So, dear brothers, make use of your meeting to speak intentionally and to listen to one another attentively, so that you may at the end of the process go out with renewed perspectives, attitudes, and actions. We should be able to rededicate ourselves to our mission of scientific research and publication. We have also an added duty to create and foster a scientific temper within and outside the society. We pray that you take this deliberation seriously and go out as men on fire to kindle other fires. Dear brothers, we have a great history in the field of science. We have some iconic Jesuits who walked the way of the pilgrim in an enriching way so as to make their life and mission more fruitful by spending their life within the confines of laboratories and scientific technological research and a life hidden pursuit devoid of publicity and glamour, but demands discipline, dedication, and daily trajectory. It's important that we go back to our history to read and reflect, recharge, and refresh ourselves so as to rededicate ourselves in this unique mission. I am glad that you are holding your meeting in St. Joseph's College, Bangalore. In fact, this college had 2 great Jesuit scientists, Father Cecil Saldanha and Father Leo D'Souza. The latter, even in his ripe old age of 90, is silently working for the Lord and his people, engrossed in research in his laboratory. Let us draw inspiration from him as well. Once again, I thank you for coming together. I wish I were there to personally greet you and encourage you. My pre-scheduled meeting does not allow me to be here. Hence, I wish you all success for your deliberation. May this deliberation help all of you, especially the younger brothers, to rise and raise the quality of life and mission so as to give greater glory to God. Thank you. So this is our first message. I have shortened this. I will send the full text to all our members later. Thank you.
Yeah, I put in the file.
Yeah, but that is also abridged. Yes.
Good morning to you, dear friends. There is no pleasing exercise other than gratitude. It seems Father Victor Lobo, he was standing with a stick in front of the gate to see who the students are coming late. Then he saw one of the girl students coming late and demanded her why she was late. As professor asked, he questioned the girl. And the girl seemed to have said, "Father, at home my father and mother are fighting." And he got the answer, but he was not happy. Victor Lobo was not happy. "If your father and mother are fighting at home, why should you come late?" he demanded. Then the girl seemed to have said, "Father, how do you expect me to come when one slipper of mine is in father's hand and another slipper of mine is in mother's hand?" Yes,
A beautiful talk rendered by Professor Ganeshan was really inspiring and enlightening. And everything begins with a question. So thank you, sir, for rendering this beautiful talk and for churning our minds and hearts with your insightful talk. Thank you so much. And much more than that, we have our dear Reverend Father Provincial, who ignited us with his spirit, ignited us with his particular talk, and he brought in the concept of sustainability. And each and every one of us have to work with this particular word, sustainability. And every one of us have different platforms, but in each and every platform, be it the synodality or whatever it may be, the Jesuits in science, each and every one of us are working on different platforms. But still, the sustainability, the word itself, is very important for each and every one of us. Father, thank you for igniting us with that word as a Jesuit provincial to all the Jesuit scientists. Dear friends, you know very well, last academic year, Father Ignacimuthu was recognized as one of the world's best scientists. And very recently also, IRC has felicitated him. And we have a role model here. And even, of course, definitely Father Vincent Briganza next to us. But we have a role model here. He is a man with the humility and simplicity, achieved a lot. And thank you, Father, for inspiring all the Jesuits in science year after year and for being with us and walking with us. Thanks a lot. And thanks a lot to Father Swibert, Father Victor Lobo, and the community who are here for hosting this Jesuits in Science meet these 2 days. Thanks a lot for calling us into this beautiful campus, and really we appreciate you for the beautiful ambience that you have created, and you are into university. We appreciate you and congratulate you for the great tasks that you worked for and achieved. So thanks a lot for inviting each and every one of us. And much more than that, my friend Xavier, we are companions for years. Though we hardly meet, but we interact. And he is really one of the great budding scientists. I vouch for it. And my wishes always stands for Xavier, because he is a very hard worker. Not only hard worker, suppose during philosophy, of course, those days we used to be a bit lazy. Xavier, I want to play tabla. Macha, I will be there, you used to say. And right in the beginning of the mass, he will not be seen. But when we are about to start the bhajan, he will be there and he will be playing the tabla. So thank you, Xavier. Thank you for meeting you after long years. And also thanks for all the eminent persons, organizers and all, for helping us to have a good stay. Thanks a lot. God bless you.
So, COVID-19 was a threatening affairs for us to gather here. So, Father Ignacimuthu used to ask me, would we be able to meet physically? I said, Father, no problem. Corona has given us a gift of Zoom, Google Talk, WebEx meeting, whatever. So today, for those who could not come, we also made it possible for them to witness this great event. That was because possible with Father Olvin Vegas here, my good friend, Persian companion, and Sharon in the community, the young scientist who will also join us. So I'm grateful to both of them for making it available for those scientists who could not join us, and for those people in our contacts who could witness this inaugural ceremony at least. Thank you, Olvin, for your wonderful availability time. A special note of gratitude to Father Swibert, Victor, and Dr. Melvin Colasso, who made this room available for us. Because any time during this week we are supposed to have a visit by the government team to declare us to a university. But I said Saturday, Sunday they will not come, give us this room. So we got it. because of their generosity. Thank you one and all. We are right on time for our tea break. Immediately we'll go for a group photo.
First photo.
Yeah, from here, group photo. The photo cameraman will guide us to the spot just outside this building here. Then we'll go for a cup of tea. Okay? Thank you. Thank you very much.
Thank you. Washroom here.
Washroom just in the next room, right side, for the principal office is there. Okay? Also, the place where we are signing, just at that place, there are washrooms for us.